everybody, it's Miss Smith. So today we've got just a couple of things that we're going to talk about, and we're going to finish up the unit today. So we're going to talk about a little bit more about isotopes. We'll talk about average atomic mass and just a few other things, just to finish up and get ready for the exam this week. So later on today, the other part of today is you're going to be, that's tomorrow. I want to remind you, tomorrow we have a live lab. We're going to talk about the chemistry of fireworks, and so I will actually be setting things on fire, but I will talk about, I may ever talk about it today, I may go ahead and do that today, about why fireworks have the colors that they do, like what's the chemistry behind that. So we'll get into that today. So I'm going to go ahead and go into my notebook for today. And let's talk about isotopes a little bit more. Now, when we talked about isotopes the first time, I'm not 100% certain that everybody understood it. So I'm just in case you didn't, I'm going to go ahead and go over it again. Even if you did, it's great to do this information again. So let's talk about isotopes. So isotopes are when you have an element with a different number of neutrons. Okay, so if you have a different number of electrons, that's called an ion. If you have a different number of protons, that's just a new element, okay? Because protons are the identifier. It's basically, it's not the name of the element, but it identifies the name. Identifies the element. So if you have a different number of protons, then you have a different element. Okay, but if you have a different number of neutrons than the regular atom, then that means that you have an isotope of the same thing. So let's get into some examples of what I'm talking about with isotopes. So a great example that I like to talk about is carbon. So I don't want you to get confused when I say isotopes with the word allotrope. So an allotrope of carbon would be diamonds are made of carbon. Graphite that's in your pencil is made of carbon. Charcoal is made of carbon. All of those are strictly carbon substances, but they all have different shapes. That's an allotrope. That's not what I'm getting at here. What I'm talking about here is an isotope, different number of neutrons. So this has to do with the subatomic level, not what they look like. This is at the subatomic level. Okay, so let's go ahead. Let's do a neutral carbon. Okay, so carbon, we're doing a little review. Here's our 8th man. So A stands for atomic number, which is equal to the number of protons, which is equal to the number of electrons, and then man, ape man. M is mass number. Remember that mass number is rounded. Always have to have a rounded mass number. Mass number is always rounded. Okay, minus A, which is atomic number, is equal to your number of neutrons. So let's figure this stuff out for carbon. So carbon is element number 6 on the periodic table. So let's go back up here to our periodic table. Carbon is element number 6, and this is carbon here, and we've got a mass of 12.0107. Okay, so let's go back down to our notes here. So carbon has an atomic number 6, and it has an atomic mass, or average atomic mass, of 12.0107. Now, so from this information, we can figure out quite a few things for carbon. So carbon, because of its atomic number, is going to have 6 protons and 6 electrons. We know that because atomic number is the same as the protons and electrons. Well, the atomic number was 6, that means I have 6 protons, 6 electrons. Now, to figure out the number of neutrons, we have to round this number to the nearest whole number, because this number is the average atomic mass. That's not what we need to use here. We need the mass number because it's got to be rounded. So the mass number for that is going to be 12. Okay, so that means that this mass number is 12. The atomic number is 6, so 12 minus 6 is 6. Now, so that means that I have 6 neutrons as well. Now, this is a neutral atom. Now, it is not neutral because all of them are equal to each other. That's not what I'm getting at. It's neutral because it doesn't have a charge, okay? It's not an isotope either, okay? So this is the non-isotope carbon. Now, let's get into another carbon. Okay, so this particular isotopic carbon is called carbon 12. And the way that you get this number here, is you have to add your neutrons and your protons. You add those together, and that gives you, so that's actually what's inside the nucleus, the protons and neutrons. Electrons are on the outside. So you add your protons and your neutrons, and that's where this number comes from. So that's carbon 12. So let's look at a different one. Let's look at, because there's one called carbon 13. They use carbon 13 and carbon 14 used in radioactive dating. So carbon 13 means that the mass number is 13. That's what that means. The mass number is 13. So carbon, your protons are still 6. Because remember, we didn't change protons. My electrons are still 6. We didn't change electrons. These are isotopes. So I just changed the neutrons. Now remember, this was the mass number here. So mass number minus atomic number equals neutrons. So the mass number according to carbon 13 is 13. The atomic number still stays the same, that's 6. So I now have 7 neutrons. Okay, same thing with, let's say that you were given carbon 14. Okay, this 14 is the mass number. We're going to do mass number minus atomic number, and that's going to equal our neutrons. Okay. Protons are still 6. Electrons are still 6. It's the neutrons that are changing because we're dealing with isotopes. So the mass number came from here. That's carbon 14 minus the atomic number of 6. That is 8. So I have 8 neutrons. Okay, so all 3 of these, carbon 12, carbon 13, carbon 14, all 3 of them have the same proton, same electron. The only difference between carbon 12, carbon 13, and carbon 14 are the isotopes. Are the neutrons. That's what makes them an isotope, is the neutrons are different. So let's talk about what happens, what do you do with these, okay? Now, when you're figuring out the mass number, okay, all you do to figure out, if you were going to try to figure out the mass number, you're actually, to be technically correct, is going to be your protons plus your neutrons. So for carbon 12, it was 6 plus 6. That was carbon 12. For carbon 13, it was 6 plus 7. And for carbon 14, it was 6 plus 8. Okay, so these are your neutrons, these are your protons, this is your mass number here. Now what happens is, these are the mass numbers, okay? On the periodic table, there's a reason why